webinar. We planned to have our usual Nordic Tech Tour in Germany this year, but as everyone knows, COVID-19 has changed that plan. And so as a result, we decided to host these little mini webinars. And the purpose of this webinar is really just to introduce you to some of the key topics we would have discussed during the Nordic Tech Tour. I would like to move on to the next slide and introduce the presenters. First of all, my name is Thomas Page. I'm responsible for the German market for Nordic Semiconductor. I work as a regional sales manager. And joining me today is Martin Lesund. Martin is an application engineer working in our Trondheim Design Center. And Martin will lead some of the technical topics we'll discuss today. In terms of practicalities, first of all, the agenda today is pretty straightforward. I will do a very brief introduction to Nordic Semiconductor. I'll give you a quick update on how it's going with Nordic and what we see happening in the future. And then I'll hand over to Martin, and Martin will introduce, first of all, our NRF Connect SDK. He will also talk about the nRF53 family, which is our new family of Bluetooth socks. And he will then end also with the nRF91 series, some updates there. The duration is around an hour. It could be a bit longer depending on questions and answers. And we certainly encourage questions and answers throughout the webinar. First of all, you can ask a question in the top right-hand block that you'll see on your screen. These questions will be anonymous. You can also ask questions in the chat at the bottom right-hand field that you'll see on your screen. These chats are not anonymous and everyone will see them. We have a team supporting Martin and I today who will answer those questions. So please feel free to ask them at any time during the webinar. We will also have some giveaways. I think the first 5, we'll put all of the attendees into a draw, and we'll send to the first 5 we choose one of our SDKs. We will do that at the end of the webinar, and we will contact the participants by Monday, the end of business on Monday. We will also send out a survey. We ask you to complete that survey, and once done, we can also make the presentation then available to you. We would also like to announce that following this webinar, we will also launch a series of additional webinars next week. We have one on the 12th of May where we will do a deep dive into the NRF Connect SDK. On May 14th, we will do an introduction to Bluetooth Low Energy. We see Bluetooth continuing to grow. We see new customers starting to use the technology, and we felt it was important to actually do an introduction to the technology for those that have never used it before. On May 18th, we will have a Nordic partner webinar, and we are pleased to have Wirepass Mesh join us to present what they are doing in terms of massive IoT deployments. And then on May 19th, we will do an introduction to cellular IoT technology. We also would like to remind delegates attending that we have done in the past, and you can change the slide, Martin, several interesting webinars that you might be keen to look at. We did a webinar on cellular IoT development on our Thingy 91. We did a webinar on the nRF5340, and we also did a webinar on our new NRF Connect SDK for the NRF 9160. So if any of you are using these products and would like to get an update on them, please go to webinars.nordicsemi.com and you can find these webinars we held in the past. Thanks. So what I'm going to jump straight into then is Nordic's offerings. And I'm going to start off by sort of doing a quick introduction to Nordic Semiconductor. We are a fabless semiconductor company and we specialize in ultra-low power wireless connectivity and embedded processing specifically for the IoT space. We have spent many years developing our Bluetooth low power offering, and we are now expanding also into cellular IoT with LTE-M and NB-IoT technologies. We were founded in 1982. We're very close to 800 people employees, 780 employees today. And we have our primary research and development centers in Norway, Finland, Poland, and we have a growing team in the US as well. Good. So Nordic is pretty well known in terms of Bluetooth low energy. We are a clear market leader in this space, and we see ourselves maintaining market share in terms of Bluetooth low energy of above 40%. What's really exciting about this is that we maintain our market share in terms of the number of certifications we achieve every year. But more importantly, Bluetooth as a technology is growing quite significantly. And so we continue to ride the Bluetooth wave, and we continue to add features and functionality as the Bluetooth SIG introduces new standards relating to Bluetooth low energy. Thanks, Martin. We also invested a significant amount of money into cellular IoT. We introduced our first product last year in June. This was our NRF 9160, a product that supports LTE-M and NB-IoT. And we have a really strong following on this product today with several design wins now starting to ramp production. And we see this technology contributing significantly to our revenues in the long term. Our solution is very, very low power, and we now have a pretty high confidence level in terms of being able to service applications that are battery powered and that require very low power consumption. We continue our strategy of building our success on 4 important pillars. The first is we lead on connectivity. We really look at having the lowest power solutions with very high performance levels. We try to put as many features into these products as possible, but most importantly is we try to make them as reliable and robust as possible. And our market penetration certainly shows that we are able to do this. We like to excite developers. We make our products as easy as possible to use, and we really try to bring as much value-added integration as possible for developers. We also have a very important customer engagement model. We can support a broad market of customers with special focus on tier 1 customers, allowing us then to address the widest possible range of customers possible. We then try to also make our solutions as scalable as possible. So we do that in terms of scalable across technologies, across markets, and across the wide range of customers that we support with our products. Our product line in terms of Bluetooth low energy is pretty well developed today. We have in the market on the left-hand side our NRF51 products. These are in full production. They are mature product of devices, and we continue to support those for production in the long term. In terms of new designs, we focus very heavily on the NRF52 family of devices. And if you look at this family of devices, you'll see we support baseline products like the NRF52810 and 52811. We then also have a family of mainstream products like the NRF52832. And then we start moving into our high-end products, the NRF52840 being one of them. And recently we introduced also the NRF52833, which brings a lot of value to customers in applications such as lighting. We see the NRF52 as a long-term family of products where we continue to invest in new products. And we just recently also introduced the NRF52820, which is a product that sort of fits well between the mainstream and baseline products, and it brings features to our baseline families such as a plus 8 dBm output power, as well as support for 802.15.4. And this will continue to be our strategy. We see ourselves defining new NRF52 products and introducing these into the marketplace. At the end of last year, with a lot of excitement, we introduced the NRF5340. This is the first part in our NRF53 series. And this part was significant since it's a device that introduces our first dual-core solution to our Bluetooth low energy product lineup. Martin's going to spend some time talking about this, so I'm not going to introduce it in much detail in this slide. Nordic moving forward, we continue to grow in terms of our short-range wireless offering. Bluetooth is forever changing with new features, so we continue to support those. We've also added significant support for technology such as Bluetooth Mesh. Zigbee from Nordic is gaining a lot of traction, and certainly Thread is significant for us moving forward as Thread's adoption continues to grow in home automation applications. We're expanding continuously into cellular IoT, and we're building our offering around this to support emerging technologies that require long-range communication. And we continue to strive towards being a full solution provider. We want to be a one-stop shop where we provide as much as possible in terms of the ecosystem customers need. So we provide ICs, we provide modules, we provide software and development tools. We try to offer as many reference designs as possible. We provide solutions for proof of concepts, and we do this also around our new cellular IoT product line. This is kind of a summary of Nordic at this point in time, and I'll hand over to Martin, who will then dive a bit deeper into some of the more technical subjects. Good, thank you. Martin.
Thank you, Thomas. So my name is Martin. I've been working in the Nordic Tech Support group for almost 3 years now as an application engineer, and I daily help out customers with questions and projects, mostly answering on our developer zone. So I'm going to have a little crash course into the new NRF Connect SDK, which will be our new SDK for which is a common platform for our cellular IoT solutions and our short-range wireless development. So let's look at the SDK alternatives. So we already have the NRF5 SDK and the soft devices, as you may know if you have been working with NRF51 or NRF52. These are SDKs that already have production-ready Bluetooth 5.0, Bluetooth mesh support, and Thread and Zigbee support. It will still be fully supported by Nordic with technical support for new projects and also maintenance releases if there are any bugs that needs to be fixed. So why would you choose to use the NRF5 SDK for new projects? You could, of course, use it if you're already using NRF5 SDK and don't need the new feature sets that will be introduced in NCS for new products. And also if you are a customer that's more comfortable using NRF5 SDK and don't need a real-time operating system. And with NRF Connect SDK, NCS for short, we introduce the support for LTM, NB-IoT, Bluetooth 5.1, and also the next in line will be supported. Bluetooth Mesh, Thread, and Zigbee will come. It's not yet supported, but it will be soon introduced. So why would you choose NRF Connect SDK? Well, the NCS has a real-time operating system, which is Zephyr. It's open sourced and built up to be as low power as possible on the hardware. And if you want running on RTOS or it's required for your product development, then this is a nice choice. Also, if you need the newest standards from Bluetooth Low Energy features or the latest Nordic features, this is the way to go. And also, NCS introduces more advanced tool chain and version control that you can use to develop on. I'm going to talk more about the source code of NRF Connect SDK. So our source code is hosted on GitHub, and we have several repositories. So the main ones, which are handled by Nordic, is the ones with the prefix NRF. We have the standard NRF, which is the main repository, NRF-xlib with the libraries and drivers, libraries, and NRF-x with the standard hardware drivers. So we make we have the code for the DFU solutions to upgrade your devices either through serial, Bluetooth, or cellular. We also have the secure partition manager and the drivers you need for working with our NRF devices, and also the integrations of Thread and Zigbee. And we have also brought the Bluetooth Low Energy link layer from the soft device, and also the multi-protocol and coexistent support into our NCS. So this is, like I said, exclusively written by Nordic Semiconductor and focus on optimizing it as much as possible for our hardware. It's licensed with Nordic 3 class and 5 class BSD license, which can be seen as more or less as an open source license. If you need to use the code for something or send it to someone else, etc., you just copy the license text and you should be good. And with the introduction with Zephyr, we get much for free. We use many open source repositories like the Zephyr project repository and the MCU boot for secure bootloader. So you don't have to rewrite code for things that is very generic and of course can be reused on a high level. So we don't need to use time on writing this again, and instead focus on optimizing things that are closer to the hardware. So we can use for cellular IoT, for example, we use the CoAP or MQTT protocols in the Zephyr project, and all these blocks you can see on the right side here. Of course, Nordic also makes pull requests and add code and value to these projects, and also checks for the quality if there's some issues with the libraries or drivers we will of course fix that so it's up to the quality that we need for our devices. And open source software repositories are with the typical permissive OSSS license, the Apache 2.0. And we, like I said, we work with hosting the external project and contribute to it. So together, this is the NRF Connect SDK. Open source code and code written by us together is the whole software development kit we provide. So to handle all these repositories, we have this tool called West, which is managing all the repositories very easily by in this West YAML file. We have pointers to the different versions of the repositories that are true and tested and works together. So just a few lines of code in commands, in the terminal, you get everything you need up and running. So, for example, for our tagged releases, as we call them, for NCS, they are tested releases with repositories and typical production releases. You have a special West YAML file that points to the correct repositories that are true and tested and should be good for you. But of course, we have this master branch that is continuously updated. If you need the newest features for development, you can, instead of using the tagged releases, use the latest development branch and get the latest features. This is good, for example, if you find a bug or something that you need fixed right away. You could just send that to the technical team in developer zone and dev zone that you found a bug and you need this fixed, and then we issue a pull request, or you can actually issue it yourself, and it would be more or less merged pretty quickly if there's a critical fix. So this has happened before by customers finding something and we fixing it just in a couple of hours, and they can go right to the master branch and get it right away. So instead of the usual waiting several months for the NRF5 SDK, the old way of doing it, you have the zip file and you would wait several months until you got a fix for the bug you reported, for example. So you get access to features and bug fixes much faster if you want to during development, or you can stick with the tagged releases. And this approach also makes it easy for your own sake. If you have private repositories with your own libraries, your own middleware, your own drivers, if you have a big organization that work together with the code base, it's very easy to put this together and just point those repositories in the West YAML file, and you should be able to access all these correct versions of every driver and what you need between your colleagues. You can just share this West YAML file and you're good to go and set up the environment. So this simplifies this very much when working together. And it's very easy to scalable development for multiple projects and multiple teams in your organization as well. So I'm going to talk more about the tools around NCS. We have support for the Segre Embedded Studio IDE. It is used for configuring your code and debugging. It's free to use for Nordic devices, and we have a good integration with the CMake and kconfig integration that's in NCS. We also have the OSS platforms Zephyr and MCU boot support, which is open source solutions. And also we are using the enterprise tool chains like Git for version control, GitHub for hosting, and also the device tree to configure the different pins, the GPIOs for the devices. And also we have CMake support. So you have the newest features, mostly for configuring, building, and continuously integrating your products. And of course, we have support with all our development boards. We have proof of concepts. For example, the picture here is the Thingy 91, which has several sensors to easily prototype your application. And also we have all the development kits for the 91 series and 53 and all you need to start developing and testing out. And also we have support for third-party board support. So on the left side here we see the NRF Connect SDK with all the things it includes, and on the right side we see the supporting components in this NRF Connect platform we have. So we have this unifying platform, support for all Nordic ICs from the 52 series and upwards. It will support all the Nordic wireless technologies, the Bluetooth Low Energy, Thread, Zigbee, LTE, and VoT. And it also provides a complete solution from board to cloud. So, for example, if you buy the NRF91 DK, you should be able to connect to our NRF cloud solution in a couple of minutes and start testing and prototyping. We also have this modern approach with the real-time operating system integration for complex designs. And also open source are used when and where it makes sense. This is a modern development and distribution model that we like, which makes it very scalable for low to high complexity applications. So very constrained memory devices benefit from this approach. So you can pick and choose only the features that are needed in your application instead of just using up space from a binary blob that you don't need everything from. For example, the soft device, you need to use a lot of space and you maybe don't need all the features from the soft device. So instead here you can just pick and choose what are suited for your application. And then you would save memory and also optimize your application in that way. It also, it's very scalable for single core and multi-core SoCs. So this makes it very easy for customers to focus just on application. So from the supporting components, we have the cloud applications and tools, NRF Cloud, and also Segger Embedded Studio, IDE support. We have, of course, PC tools for logging, etc., and also mobile tools, apps to work with our devices, as well as the hardware designs and kits. So how this NRF Connect series support has been provided. We started with the NRF91 series with support for development in end of 2018 and released a support for production last year. So this was the first device we went with the NRF Connect SDK, and the next one was the 53 series, which got development support in end of 2019, and we will get production support and release with the silicon at the end of second half 2020. Also, support for the 52 series has been, there have been unofficial support for the 52 series in Zephyr, but now we will officially support it in NCS by Nordic. So that is launched, but like I said before, we will not discontinue the NRF5 SDK and soft devices. So if you want to go that way, that's up to you. So that was a short introduction into NCS. Now we're going to talk, shift gears a bit and talk about the direction finding feature that was introduced in Bluetooth spec 5.1. Here we have it was introduced with angle of arrival and angle of departure. We will have proof of concept reference design end of 2020 now, with hardware and firmware, so you can start developing and testing this out. So basically you have two devices, a simple beacon, a simple tag, and an advanced locator. So this simple beacon can be a small chip with a single antenna that sends data, as well as some phase data at the end of the packet to add to the locator, which has several antennas. And the locator will take this data, combine it with the array of antennas, and find the degrees which the device is located in. So for direction finding, you would usually have several locators, like you can have 3, for example, and then you can use this information from all the locators to find the more accurate direction from the device, instead of using the standard RSSI that you may know from before. So this is in new features that we will support, of course. And the next one would be the Bluetooth Low Energy audio support. So this is something worked by the Bluetooth SIG group. Parts of the specifications is already released, and we're waiting for the remaining work, so this specification can be done, so we can release our development kits and reference designs, so you can start testing this out. So the main changes compared to Bluetooth Classic that is already in use from in the cars, in headsets, etc., that you may know from before, is that this new feature utilizes the Bluetooth low energy physical layers, and also introduces a new audio codec, which is a low complexity communication codec. You can achieve same quality as Bluetooth Classic, but with much lower power, or you can increase the bit rate and get a much higher quality. So it depends on what your application needs and what you want to focus on. You can get very good if you have a smaller bit rate. You can have a much stronger connection and also longer range and better power consumption. So it will support connected mode, which is very similar to the Bluetooth Classic. You have one device connected to another one and stream audio. But you also have support for multiple synchronized streams. What this means is you can have 2 separate earbuds, for example, that get streams directly from one device, and you don't get this latency. So now you have the Bluetooth Classic approach, where you stream to one device, one earbud, and the earbud needs to send this data over to the other one and also synchronize this. This causes much complexity in the earbuds itself and takes up space, costs more money. So you can really simplify your earbuds much easier having this approach instead. You will have better battery life, and also you have better space if you want a larger battery in the earbuds, for example. And it will also support broadcast mode. So one device can broadcast to several devices. This is, for example, an application where you have a theater or a movie, and you can broadcast in different languages to different channels. So you have the audience with headsets or which have their own language streamed to their devices. Now we're going to jump into the nRF553 series, which is the new multi-protocol platform. So we released the nRF5340 recently, and here is the overview of the system on chip. It has an application processor and a network processor. So what to take from this is that we have this high performance application processor, which is very based on performance, and the network processor where is very optimized for low power and efficiency. Both are programmable. You can program both processor and also mix and match how you would set this up. I want to talk about that a little later now. It also introduces the advanced security features, redesign of the multi-protocol radio, and also we have a larger supply range from 1.7 to 5.5 volt, and also temperature range for -40 to plus 105 Celsius degrees. So why this new multi-core flexibility approach here is because usually embedded designers, software designers, there's always a trade-off between performance and high efficiency. With these two cores here, you don't need to trade off anything. You can have both. So you can optimize for performance and optimize for efficiency for your application using this approach here. And you also get the separation of concerns. If you have real-time requirements, you can process those in the network processor, and things that doesn't need real-time critical interrupts can be run on the application processor, for example. And you also have this software split. Yeah, so let's talk a little bit about the radio improvements. This is compared to the 52840. So the TX peak current was reduced with 30%, so down to 3.2 milliamperes. And also the RX current reduced with 40%, down to 2.6 milliamperes. Also the RX sensitivity has been improved from 96 to minus 97.5 dBm. And also the 1 dB resolution of TX power support. All in all, here's the NRF5340 system on chip with the shared power and clock, power supply with support for LDO, buck DC-DC. Also you have the clocks 32 megahertz and 32 kilohertz. And also you have this audio PLL, which comes in handy for your audio applications. And you can see from the application processor, you can choose between 64 megahertz and 128 megahertz, depending what you need in your application. We're going to compare those soon. And also you can see that the application processor has a larger memory and RAM, also a larger cache, more peripherals, and also the network processor has the 64 megahertz M33, and it also has a couple of peripherals, but it's optimized for power, so you don't get a leakage current if you have several peripherals, for example. Yeah, so the application processor, like I said, it has the ARM Cortex M33 with DSP and floating point instructions. It can be running on 128 megahertz and 64 megahertz clock speeds. It also supports voltage frequency scaling. It's optimized for performance. It also has this trust zone support. I'm going to talk more about that very soon now. And also this 8 kilobyte two-way set associated cache. So you won't get this latency from the MCU talking to the flash. And you have this big flash and RAM in this application processor. For the network processor, you have the M33 running on 64 megahertz. Clock speed, it's optimized, like I said, for efficiency. It's of course fully programmable as well. It has a smaller instruction cache and a smaller flash and RAM. So let's look at the performance and the efficiency of the different options you can have on the 5340 compared to the 52840 down on the left side. So to measure the performance, we get a number called the core mark number, and also the efficiency is measured by the core mark per milliamperes. So as you see down in the left, we have the 52840 running on 64 megahertz. It has a performance core mark for 212 and an efficiency of 64 core mark per milliampere. So just to compare the application processor on the 5340 running on 64 megahertz in the middle here, you actually get increased performance and also very increased efficiency, as you see. But on the top left side, we are actually running the application side in the 128 megahertz. You see that the performance drastically increases up to 510 core mark, and also it's on par with the efficiency as the 52840 on around 65 core mark per milliamperes. And the last core is the network core running on 64. It has better performance than the 52840, but a lot greater efficiency with 101 core mark per milliampere. So if you are running, you want the best of both worlds, you can run the application at 128 and a network core, of course, on 64. You would get the core mark score for about 740. So then you get great performance and also great efficiency. Now over to the power and clock domain. We have support for 1.7 to 5.5 volt supply, LDO and DC-DC options, of course, and you can also directly supply it from USB. We have, for oscillators, we have integrated load capacitors, so you don't need to have external ones. This will save some cost in BOM. And we have the 32 megahertz and the optional 32 kilohertz crystal integrated. And also we have the tunable on-chip audio PLL, which is very much needed for those kind of application where you need to stream and synchronize two devices at the same time, for example. So how are those two processors communicating? You have this inter-processor communication, short IPC, which sends events and data between the two processors. It generates the events across the domains and can also be used as a wake-up source. So if you have one critical software running on one core and it stops working, you can easily wake that core up again from the other core. And you also have cross-domain memory shared and peripheral access, so you can share memory between two cores up to a limit. And also we have this open AMP, which is the software framework for asymmetric multiprocessing systems, the API that's used between them. So a new introduction in the 53 series is this DPPI. It's that replaces the regular PPI in the 52 series. It's distributed programmable peripheral interconnect. So this new interconnect interfaces can interface for peripherals. This new DPPI benefits that you can have more connection types. So you have the regular one-to-one, which is just regular PPI. You can have one-to-many, many-to-one, and many-to-many. So this is quite good if you have peripherals that need to talk to each other through tasks and events. Instead of going through the CPU, you can directly do it through this DPPI and save memory and also increase speed for critical GPIO button presses to wake up something or do something, you can of course use this DPPI. Now to the ARM Trust Zone feature. This is how the cores are divided. So the M33 cores have this non-trusted zone and this trusted zone, or also known as secure region and non-secure regions. So what you can have here is stuff that should not be accessed by the non-trusted zone in the trusted zone, and also you cannot access the things you have in the trusted zone from the non-trusted zone unless you have implemented some special instructions to call the secure code, but that's up to you programming in the trusted zone. So when you boot up a device, you jump into this trusted zone, you set the flash area and the RAM area that the non-trusted area can access, as well as the peripheral it should have access to. So this is a very good secure feature. As well, you have this flexible debugger access, so you can actually choose what the debugger can access. If you have a device in your field, out in the field, you can already, that you need to debug, you can on beforehand program that the debugger only can access a certain amount of the device. And with we also have this new CryptoCell 3.312, which is the update from CryptoCell 3.10. This introduces stronger encryptions with the 256-bit AES with GCM and up to 3072-bit RSA. Also, we have support for cryptographic operations in Flash, so we don't need to use RAM for that. Another features are that the cryptographic backend support to embed TLS. Also, we have certified true random generator, and also we have the feature for firmware image validation. So this is really nice to have for when you have updating your firmware. You can actually check that it's the correct firmware and not the firmware from a hacker, for example, that is going to update in the device. And you also have this hardware root of trust feature, which you can, for example, save keys in. That's important. So we're going to look at that now. We have this key management unit, or key MU. It is connected to the processing system through an APP layer. It can only write to this key MU unit. It cannot read, so it can be looked at as a one-time programmable memory. It has support for 128 key slots with 128-bit keys, but of course you can combine those keys for larger keys. And this approach here is that only the CryptoCell can read out these keys through a separate secure APP bus. And this KeyMU also supports key revocation. Yeah. So all this together makes the system on chip very secure. You have the trusted execution with the ARM trust zone, the separation from the secure and non-secure area, where you select the flash and RAM and the peripherals from the secure area to be used in the non-secure area. And also we have this state-of-the-art ARM CryptoCell 3.12 with advanced cryptography and also this hardware root of trust. And of course the secure key storage with the key management unit. So all this together makes this device a very secure device. Yeah, so now let's look at the different approaches you can have in the software architecture. So here we have separated the application processor and the network processor. On the left-hand side, we have just running user application on the application processor and the standard protocol stack on the network processor. This is an easy approach and should work fine based on your use cases. And also on the right-hand side, you're running the user application on the application processor, but you are running several protocol stacks on the network processor. For example, Bluetooth Low Energy and Bluetooth Mesh, for example, they can work together. In the middle here, we have user application code running on application processor, and also the high-level protocol stack that needs some more performance located here, but also the network processor is running some user application and some low-level network stack for better efficiency. So this middle approach here is something that we have examples on already in our NRF Connect SDK. Yeah, so that was a short introduction to the 53 series. Now we're going to talk about the 91 series, the cellular platform. And here we have the Nordic NRF 9160 system in chip, which is made to make cellular development easy for customers. It's a fully certified SIP module with global multiband support and also integrated GPS. So inside the block here, you can see the NRF 91 system on chip with the application processor, which is fully programmable with its 1 megabyte of flash with cache and also 256K of RAM and all the peripherals that you may need. And also we have another CPU running the modem and also the GPS. So the modem supports LTM and NB-IoT. And also in this SIP we have the whole RF front end optimized for the device, and also the power management IC and all the passives and crystals you may need inside this SIP here. So more or less, very simplified, you just connect a power source, for example, a battery, the sensors you need, and also the SIM card, as well as GPS antenna and LTE antenna for your device, and you should be more or less good. It has very low power, of course. That's the backbone of Nordic. It has a small size and improved coverage. And it also has this ARM Cortex M33 with the rich sets of system peripherals and interfaces. So you have the trust zone and the floating point support in this device as well. For secure connectivity, you have using the cellular network, also have the end-to-end internet protocol security, DTLS and those kinds of things, as well as ARM Trust Zone and the CryptoCell technology that I went through earlier here. So the software architecture of the 9160, it's complete and it tries to be so very easy to use solution. You have the connectivity and the application software. So the connectivity is provided by a modem firmware that you just flash to the modem side, and it includes all needed to get you connected to the LTE network. Support, of course, the TLS, DTLS, TCP, UDP, the IP4 and IP6 stack, and also the LTE layer 1, layer 2 and layer 3 stacks is included in this modem firmware. And in the fully programmable application processor, you would have your user application as well as running the application layer IP stack, for example, CoAP or MQTT or HTTP or lightweight machine-to-machine. That's based on what you would like to connect to in your cloud solution. So between these two cores, you have the secure BSD socket API to talk to the modem And also we have, of course, support for over-the-air modem and application updates. So you can update your device out in the field with new modem firmware and application firmware. And as I mentioned shortly earlier, we have a reference design, the Thing in 91, which is very similar to the Thing in the 52. This one has 11 sensors and also a 52840 on board, so you can easily prototype ideas and application with this device. You can, for example, use it as a gateway for Bluetooth devices. We have samples of that in the NCS, and send those data up to the cloud, for example. And we have also support for something referenced as thin modem or serial LTE modem. That means that you can run an application on application processor, which will make the nRF9160 act as a regular modem. So you talk directly to the modem through 80 commands. So you can have an external MCU and the nRF9160 working as the modem. And now a little bit about the carrier certification plans. Verizon is not mentioned here, but they are certified. So for certification, you usually have this global certification, GCF, for the world, and for the North America, you have this special PTCRB that you need. And the nRF9160 is certified for those. But some carriers require some additional requirements, and therefore we have some ongoing carrier certifications. So right now we have Vodafone in the UK, Germany, New Zealand completed on the NB-IoT network. And also we are finished with the Deutsche Telekom carrier certification plan in Germany, and also in Austria on the LTM network and NB-IoT. For the medium term, we have the AT&T, Telstra, and also China Telecom. And we are working on the SoftBank and Bell Canada certification plan as well. So this is ongoing work, and so customers don't need to do this when they buy our device. So you buy a fully certified device for carriers instead. Yes, and now a little bit about the software release summary from November up to May 2020. So the release last year, we introduced the modem firmware 1.1 and NCS tag 1.1. So here the key contents are the Verizon certification, including the lightweight machine-to-machine device management with firmware over-the-air support. And also support for GPS used in EDRX intervals and PSM, as well as making the modem ready for assisted GPS. And also application and differential modem firmware over the air over the MQTT protocol and HTTP support. And in February 2020 now, we released the modem firmware 1.1.1 and the tag NCS 1.2. So there were no major features in the modem side, but on the software side, in the NCS, we introduced the assisted GPS client and a cloud assisted GPS features. So this assisted GPS downloads the typically ephemeris and satellite data directly from the LTE network, instead from the slow downloads from the satellites. So regular GPS can take a long time, up to 30 seconds and upwards to get the first fix, while this AGPS makes this much quicker. You can get the first time to fix between 5 to 15 seconds instead of a very long time like regular GPS, because you download the data much faster on the LTM network that you need, and you can track and find the satellites that you need in your area much faster. And also in this release we got the serial LTM modem support, which I told was the TIN modem support, so you can use the nRF9160 like an external modem with your external MCU, and also some FOTA firmware over-the-air enhancements were introduced here. Now in May 2020 we have introduced the modem firmware 1.2. The nRF Connect SDK 1.3 has not yet been released. It is planned to be released I think this summer. And this modem firmware 1.2 is focused mostly on new carrier certifications, and also extended the serial LTE modem support. Also it has some GPS improvements. Lastly, for support, we have the online technical support center and field application engineers. You contact us through the Nordic Developer Zone, which is a open forum as well as private tickets. So you can send in a question, either a private or a public one. So you can make a public case and get the answer from the community, or private one and get a directly answer from us. But of course, every ticket that comes in is assigned to a Nordic engineer, and you will always be handled accordingly. So we target a 24-hour response time, and so you should get an answer quite quickly. And we have several posts and users, and we have about 3 million page visits the last 6 months. So if you have a questions, it's usually already been asked on Nordic Dev Zone. So it's quite nice just to, for example, Google your question, and you will usually be directed to Nordic Dev Zone. And also we have the Nordic GitHub. We have the official Nordic semiconductor GitHub page, and also this Nordic Playground page with some more unofficial samples and different things, which includes up to 270 repositories with different codes written in C and C++, Python, JavaScript. It can be application from your cell phone, or demos showcasing throughput, or different kind of things that you can benefit from checking out. Yeah, that was the end of the presentation. So I think it's time for a Q&A session.
Yeah, so we have a list of questions that have been asked. Martin, I don't know if you managed to see them.
Yeah, I have them here. So the first question here, is it a system in package? Came in during the nRF Connect SDK section. Yeah, so I think it's addressed to the nRF91 zip. Yes, it's a system in package, while the 53 is a system on chip. I hope that clears up that question. And the next one is, what is the supported programming language for Nordic nRF 5340? So we use C. That's fully supported by us. And R, Python, and JS supported, not officially by us. However, there are some unofficial stuff online on GitHub. But for the best support, you should use what's in our NCS, which is C. Next question, which antenna interface it has? So the antenna interface, you can just connect the antenna through a 50 ohm connector. Yeah, I think looking into the product specification for more details could be beneficial for that question. I don't have the details more than that. Can we attach external antennas? Yes. Is the over-the-air supported? Yes, it's supported on both nRF91 and yeah. Can it be used as a gateway? Yeah, you can use this as a gateway by, for example, on the DK we have the 52840 and also the Thingy 91. You have the 52840 talking to the 91, so you can absolutely use this as a Bluetooth gateway or Zigbee gateway or whatever to send your data up to the cloud. Yes, it has I2C. We have called it TWI, two-wire interface, but it's the same thing. It has support for that. How do the two ARM MCUs communicate? I think I already went through that in the presentation. It uses the IPC communication.
But I think the customer doesn't have to concern themselves with that because there's a software layer that abstracts the communications, correct?
Yeah. Thank you. Which firmware is supported by the ARM Trust Zone? So the ARM Trust Zone is a hardware feature on the M33 platform. So NCS that we're using utilizes this Trust Zone with the secure and non-secure. So we have a secure bootloader running in a secure area and your application samples running on the non-secure area. All this is documented on NCS documentation page, and also we have samples showing this in GitHub in NCS. Do other cloud services than Nordic Cloud support the 5340? If yes, which are they? So the Nordic Cloud service is running over Amazon Web Services, and we have seen that customers has been using others like Azure, I don't know how you pronounce it, but Microsoft Azure
and Google Cloud Platform.
Yeah, and of course the Google Cloud Platform.
But I think the key message here, Martin, is perhaps to highlight that we have all the building blocks in place to connect to any cloud service. And it's just a question of configuring these building blocks to adapt to whatever cloud service the customer wants to adapt to.
Yeah, that's a good point. Thank you. Next question. Is the nRF Connect SDK with Zephyr as energy efficient as nRF5 SDK with soft device and maybe other real-time operating systems? Yes, absolutely. Like I said, you got showed some numbers for the radio, etc. for the 53. So it's absolutely more even more energy efficient sometimes as well. Yeah. Next question, how does the support for AOA, angle of arrival, look like from Nordic? Any software and hardware examples coming? So I had a slide on this, and it is coming second half of 2020. We will have some proof of concept that you can start testing and developing on. Next question, is FCC and CE certification required for Bluetooth wireless products using the 52840 in small parties to 300 pieces, and qualifications Bluetooth SIG? Do you have the answer for this, Thomas?
Yes, yes to both of those questions. And the recommendation here is always to have a look at our third-party page on our website. You will find, I think, over 30 different module vendors that provide pre-certified modules, and many of them supply modules for the NRF 52840. So you probably, in this case, it's better to use a pre-certified module with the NRF 52840 on it.
Thank you. Next question. Is any of the NRF 5X of the NRF series have real-time clock inbuilt, so applications that can work from day 6 a.m. to 6 p.m. and then sleep? Yes, that's possible. Next question. Does the power supply have integrated protection? Yeah, I'm very sure of that, but I'm not 100%. That is maybe something you should ask on DevZone to get confirmation on, or at least it should be stated in the product specification. I don't remember it. Does CryptoCell 3.12 support hash functions? That is something I'm not 100%.
Yes, it does.
Yeah, okay. Yeah. Perfect. I would assume it did.
Yeah, you can download that CryptoCell datasheet directly from the ARM website, and it will specify exactly which hash functions are supported.
Thank you. Does the power management IC in NRF 9160 provide battery charging features? I do not know if it does. No, I don't think so. You will need an external device for that.
Yep.
I think that was the last of the questions. If you have any further questions, please reach out for technical questions on DevZone. I posted the link in the chat. And
good.
Yeah.
So if there's no additional questions, Martin, thank you very much for contributing today and for leading the technical discussion. Thank you everyone for joining the webinar this afternoon. Stay safe and have a very enjoyable weekend. Thank you.
Thank you everyone. Goodbye.